Hello everyone, welcome back to the channel. This is Mr. Lee's Math Class Videos. I'm Mr. Lee. This is Math 1316 Trigonometry, Section 5.3, Part 1. So 5.3 is a very large section, so I break it into two chunks, so the homework will never be due until we've done Part 2 as well. But we'll go ahead and cover Part 1, which has some applications that kind of overlap with 5.2, but also has some additional concepts that we'll talk about, as well as some general, I would say, concepts and equations that we can use, as well as talking about the common triangles that you might encounter in trig. So as a reminder, we knew what the trigonometric functions represent in terms of a circle, in terms of x, y, and r. However, the reason that this works is that on the Cartesian coordinate, the x, y, the plane that's x, y, those always create right angles between x and y. So every triangle that you would draw on a circle in terms of x and y will always create a right angle just inherently by the way the coordinate system works. So we're extending trig functions not just to work on the circles and the angles that they come out from the center, but also to apply them to triangles. Now again, this only applies to right triangles, but it also recognizes that the angle from which you are looking is important. For example, looking at this triangle down here, angle A, what's opposite angle A is side A. So if you're doing the sine of angle A, when you did opposite over the hypotenuse, is different than doing sine from the perspective of angle B, because what's opposite angle B is different. So when they say find the 6 trig function values for both angle A and angle B, they're having you play with that perspective. So if we look at sine of A, which is opposite over hypotenuse, y, the y value change over the radius equivalent just on a triangle, you notice that it's 7 over 25, which means if we do its reciprocal function, cosecant of A, it's 25 over 7. Similarly, cosine of A, adjacent over hypotenuse, is 24 over 25, which means its reciprocal, secant of A, is 25 over 24. And then finally, we can do tangent of A, opposite over adjacent, is 7 over 24. And cotangent of A is the reciprocal, 24 over 7. Now though, if we look at it from perspective B, you'll notice that sine of B is opposite over hypotenuse. The hypotenuse is the same no matter which angle you look at it from, but what's opposite has changed, so now it's 24 over 25. And respectively, that means cosecant of B is 25 over 24. Cosine of B, what's actually adjacent to angle B is now A, side A, the 7, so it's 7 over 25. Secant of B, 25 over 7. And then tangent of A, or tangent of B, excuse me. Same two sides as it was angle A, they're just opposite, so it actually just flips. 24 over 7, and cotangent of B is 7 over 24. Now, if you look at all of these 6 values, regardless of which angle you look at it from, you'll notice they have a corresponding equivalent value from the other angle. For example, sine and cosine actually just flipped values. Similarly, cosecant and secant flipped values. But then tangent and cotangent actually flipped values as well. And there's a reason for this. In a right triangle, all of the angles add up to 190 degrees, which means if the right angle is 90 of those degrees, then the other two angles will always add up to 90 degrees. And it creates a relationship between some of these functions called cofunctions. And cofunctions have a special aspect that confirms this fact that these things are equivalent when you pick the opposite side of a triangle at a right angle. That is to say that sine of A is equal to cosine of 90 minus A, and similarly cosine of A is equal to sine of 90 minus A, and the same for secant and cosecant, and the same for tangent and cotangent. Now, reciprocal functions and cofunctions are not the same. Reciprocal functions are the ones who you would just take the reciprocal to find the other value. Those are sine, cosecant, cosine and secant, and then tangent and cotangent. The cofunctions are really easy to remember because the little beginning of cofunction is co. So what is the cofunction of sine? It's cosine. What's the cofunction of secant? It's cosecant. What's the cofunction of tangent? It's cotangent. So the naming mechanism gives away what the cofunction is to each one. So you're either adding the co to it or taking the co away from it to find what the cofunctions are. So if they ask you to express an angle in terms of its cofunction, we look at cosine's cofunction is sine. So in order to find the cofunction, you take the sine, and it's always 90 minus whatever angle the cosine was. So this is the sine of 38. Now, mechanically, this is how it works, but visually, what are we talking about? We're basically saying in a right triangle, if there's a 52-degree angle, then the other one is a 38-degree angle. So if you're doing y over r, and you're calling this x, sine of 52, or cosine of 52 would be x adjacent over r, whereas the sine of 38 is also opposite over hypotenuse, which is also the same x over r. So this is the visualization of how it's happening, but this is the algebraic method by how you would do it. So for tangent of 71, you'll take the cotangent of 90 minus 71. So you get the cotangent of 19 degrees. These two values will be the same by the similar triangle argument there. And I'll leave C for you to practice with secant. Now, this also means that you're going to get some algebraic equations where they tell you potentially that two things are equal and you need to find the variable inside the trig function. And what I'm talking about there is problems like 3 and 4. Find theta given cosine of theta plus 4 degrees equals sine of 3 theta plus 2 degrees. Because these two are cofunctions and they are equal to each other, that means the angles inside them must add up to 90 degrees. So it allows you to say theta plus 4 degrees plus 3 theta plus 2 degrees has got to equal 90 degrees. And then from here, it's just solving for the variable. So theta plus 3 theta is 4 theta plus 6 degrees is 90 degrees. Subtract the 6 degrees to get 4 theta equals 84 degrees. Divide by 4. And you get theta is 21 degrees. And you can always confirm this by plugging back in. 21 plus 4 is 25. 3 times 21 is 63. Plus 2 is 65. 25 plus 65 is 90. So you can always check and make sure that they work based on what you already know. So I'll leave number 4 for you to practice. It's very similar. And then we'll move on to about the second half of part, or 5.3 part 1. We'll get it started here on the next page. So there's some important aspects going on with your trig functions, and again, easy ways to remember them. So if you're comparing function values, which the homework will have you do, think about sine, tangent, and secant primarily are dependent on either y getting bigger or x getting smaller, or both. And if you look in a circle, if you're moving from 0 to 90 degrees, if you take a small angle, your x will be bigger and your y will be smaller, but as you get closer to 90, it actually becomes the opposite, where your x gets smaller but your y gets bigger. So in general, from 0 to 90 degrees, x is getting smaller and y is getting bigger, and that kind of creates guaranteed patterns depending on what your equation is. For example, sine, tangent, and secant are all increasing as the angle increases, because either y is getting bigger or x is getting smaller. Cosine, cotangent, and cosecant do the opposite. They get smaller because they're dependent on either x getting bigger, which it's not, or y getting smaller, which it's also not, or both. So starting in the next video, we'll reiterate that, and then we'll look at how you can use this reality to determine if the following statements are true or false.